All right. All right, good evening. My name is Alicia. I'm a software developer based here in San Diego. I do independent consulting for startups and big companies. I'm also the CTO of my own tech startup. Some of you might recognize me. I'm active in the local tech community and I give talks like this all the time. Today I'm going to be doing one on Python for machine learning. So for this talk, I'm not assuming any prior knowledge. So if you don't have a background in machine learning or data science, it's okay. We're going to be all right. So what the heck is machine learning? It's a field of computer science that gives computers the ability to learn without being explicitly programmed. Over the past decade, machine learning has given us things like self-driving cars, practical speech recognition, effective web searches, etc., etc. Why do we use Python for machine learning? I think the number one reason is that the machine learning libraries in Python are amazing. I'm going to be focusing on scikit-learn and TensorFlow. So Python has NumPy, right? So that means that vectorized operations are very fast. It's easy to build on top of that. A lot of people already have. And at this stage, I think it's easier to expand already existing libraries as opposed to rewriting everything in some other language. So first we're going to talk about scikit-learn. So in a nutshell, it's just a machine learning library for Python. It's built on NumPy, SciPy, and Matplotlib. It's used by Spotify engineers for music recommendations. OkCupid uses it for their matchmaking system. It takes care of every machine learning algorithm that you can possibly imagine. It takes care of everything from classification, clustering, regression, dimensionality reduction, etc., etc. And then TensorFlow. So TensorFlow is by Google. It's this open source library. It does numerical computations using data flow graphs. So it's used to be able to design, build, and train deep learning models. So the central unit of data in TensorFlow is called a tensor, which is just a multi-dimensional data array. And a tensor's rank is its number of dimensions. So in these data flow graphs that you have, the nodes represent these mathematical operations and the edges are the tensors that flow between them. So the reason it's called TensorFlow is because it's literally a flow of tensors. And you can use a tool called a TensorBoard to visualize these graphs, and that's what's going on this picture up on the screen here. So in TensorFlow, what's neat is that these variables allow us to add these trainable parameters to a graph, and you can also, it also provides optimizers, so you can change each variable in order to minimize loss functions. So there are a lot of machine learning algorithms out there. There's no way I'm going to have time to get through all of them. So I'm just going to cover two. One is called the naive Bayes, and the other is called the support vector machine. I'm just going to talk a little bit about the theory and how you would implement them in Python. The reason I chose these two is because they're really important in machine learning, and if you were to take like a machine learning 101 course, this is like one of the first things they would teach you. So I think this is good enough to get us going. So naive Bayes, it's a family of probabilistic algorithms where you take advantage of probability theory and the Bayes theorem to predict categories of samples. And when I say that it's probabilistic, what it means is that you calculate the probability of each category for a given sample, and then you output the category of the highest one. So you have a feature based on prior knowledge of conditions that might be related to that feature, but you'd have to decide what feature to use, right? So, for example, if you're doing a classification on health, you might want to use like a person's height or weight or something like that. And the Bayes theorem is really useful for conditional probabilities because it provides us with a way to reverse them. And the reason it's called naive Bayes is because you assume independence between all the features. So this is just an example, and I literally ripped this code directly from the scikit-learn documentation. And what I'm trying to get across here is how easy it makes it for us, where all we have to do is import Gaussian NB, naive Bayes, and then call it. And it's only a couple lines of code. The other algorithm is called a support vector machine. It's really fast, really dependable classification algorithm. And if you have a small data set, that's pretty good. It works very well. So in a nutshell, you're just finding a hyperplane that gives the distance between some training samples. So I think that would be best explained with like an example. So if you have these two data points, and here's the hyperplane that kind of separates them, the line there, so you have all the blue circles on one side and the red triangles on the other. And the best hyperplane is the one that maximizes the margins of both categories. So the best hyperplane is the one whose distance to the nearest element is the largest. So that was easy because the data is literally separable. I mean, you could just draw a straight line and you could separate the two categories. But when you have something like this, when you have nonlinear data, you have to add a third dimension. You have to add a z-axis. So you can classify nonlinear data by mapping space to a higher dimension, and you'd use a kernel function for that. And this is how you would implement a support vector machine in scikit-learn. Again, it's only a couple lines of code, and it's really as simple as just importing the library and calling a function. But machine learning, it's so much more than just calling functions with sciplotlib. Like, you really need to understand the theory behind what you're doing. So yeah, I know that's a lot to take in. I mean, the thing about machine learning is it's a very mathematically and algorithmically intense area. That's why typically the people who go into it tend to be, mathematicians or computer scientists with graduate degrees. So I always put up my contact info at the end of my talks. I welcome anybody to shoot me comments, questions, or want to get together, talk about this, or need help with a project that's related to this. That's cool. Yeah, so I'm about ready to wrap this up here.
Is that Claire Nash?
You know what? I was looking for a picture that I could just copy and paste, and that's the one on my Twitter. Yeah, sorry guys.
That's cool.
Okay. Alrighty. So if there are no questions.
Any other questions? Question? Sure.
So within within the machine learning, it looks like a lot of that functionality is built into it. So how do you? I mean, I guess it is within the field you're programming, trying to make the model